Generally, this should be the shape in general. Okay, so this becomes your true shape. Is it clear, students? Students, is it clear? So I didn't mention the height of the solid. What was the height of the solid given it is? Height of the solid is given. Okay, students, shall we move to the next problem? Had you copied? This పెట్టావా పెట్టాం మమ్మీ ఫోన్ నుంచి పెట్టావు రాని Students, can I erase this? All of you write a problem. A right circular cone of base diameter base diameter 40 and height 60 resting on its base on HP, resting with its base on HP, and it is cut by the section plane perpendicular to HP and making 25 degrees inclination with VP. And making 25 degrees inclination with VP and 8 mm away from the center of the base and 8 mm away from the center of base. Draw the sectional front view. Draw the sectional front view. Come on. Top view and true shape of the section and true shape of the section. All of you read the problem. A cone of base diameter 40 and height 60 is resting with its base on HP like this, resting with its base on HP, and it is cut by the section plane perpendicular to HP like this, perpendicular to HP. So until now we just see the problems. So base is resting on HP and your cutting plane is inclined to HP and perpendicular to VP, and it is supposed to cut in this pattern. But now the base is going to be like this and your cutting plane is perpendicular to HP and it is supposed to cut the solid like this, like this. Okay. So where it is going to be, it is going to be making 25 degrees inclination with VP. VP inclination is some 25 degrees. So let us see, it is going to be VP inclination is like this, 25 degrees, and it is cut in such a way that where it is going to be cut. So at which point means, so it is some 8 mm away from the center of the base. 8 mm away from the center of the base, it is supposed to cut the solid. When it is supposed to cut the solid, here this portion, some of the portion is to be removed, okay, and the sectional portion is seen in the front view. For that only he just asked to find the sectional front view. Until now the problems which we see in your cutting plane is going to be perpendicular to VP. If it is cut like this, you are going to see the sectional top view. Now your section plane is perpendicular to HP and it is inclined to VP. If it is cut in this pattern, sectional view is going to be seen from the front. So it is sectional front view. Let us see how it is obtained. All of you try this problem. All of you try it. Try to put the simple position. So we will do this problem, no problem. First of all, try to put the simple position. Okay. So I just remove this line for my convenience. So draw the projections. So the question is there, draw the projections. Okay, so let us divide into 8 number of equal divisions for my convenience to obtain the smooth curve. Okay, students, let us do this problem. So divide these points. So this is A, B, C, D, E, F, G, H. So this was a cone. So it is O1 of O2. Okay. So we know the diameter of the base of the cone is given as, it is diameter 40 and height is given as 60. Okay. Okay, for cone we just had to highlight only the N generators. So, but for the section of solid, I had to consider the remaining generators also for obtaining the points. Okay. So this was O1 dash. So this becomes your A dash. This is B dash of H dash. This is C dash of G dash. This is D dash of F dash, and it is E dash. Okay. So this was your step 1 and it is step 2. Now let us take your cutting plane. How your cutting plane is perpendicular to, your cutting plane is perpendicular to HP and inclined to VP. So if it is cut like this, means when you are supposed to see from the top, in the top view, you just see the trace of the cutting plane. That is, the line is going to be seen, which is, we call it as your horizontal trace HT. Okay, so where it is going to be passing, it is making 25 degrees inclination. So that means coincide your drafter to 25 degrees and fix your knob, and where it is going to be placing on. So that means it should pass 25 mm from the, 8 mm away from the center of the base. So that means you simply, what you should do is draw the circle of radius 4. You just draw a circle. You just draw a circle of radius 4 mm. For example, let us consider. So this was the diameter of 8. Okay. So this means, so wherever the point, if you just consider it anywhere, it is going to be 8 mm away. Okay. So 8 mm away from the center of the base. Okay, 8 mm. Take your center and 8 is going to be your radius. So draw a circle. Okay, that means from the base, if you should measure, it should be 8 mm. So take 8 as radius, O as center, describe a circle. That means from center, if you consider anywhere of the point on the circle, it is 8 mm away from the center of the base. Okay, now the cutting plane is going to be making an inclination of 25 degrees also. So you just draw your cutting plane, which is inclined some 20 degrees. Okay, and it is passing through like this, and it is supposed to pass through like this. So that means this inclination, let us consider this inclination is going to be somewhere, it is some 20 degrees, I think, consider. Okay, now so this was to be highlighted by the ends are thick, and its centers it was thin and dot. Okay, now mark the intersection points. Now mark the intersection points where it is supposed to cut. So first of all, it cuts the base edge. So it cuts the base edge at here. So this becomes your point 1. So it cuts your base edge at here. This becomes your 0.1. Next, it cuts the generator OC at 2. Generator OC at 2. Next, it cuts the generator OD at this point. This becomes your 3. Next, it cuts the generator OE at particular point. This becomes your 4. Next, it cuts the base at FE. This becomes your 0.5. Okay, students, it cuts the FE base edge and at center in between F and G, and I just obtain my 0.5. Okay, this becomes your 1, 2, 3, 4, 5. Now, this becomes your horizontal trace, HT. That becomes your horizontal trace, HT. And height of the solid, we know the height of the solid is 60. Okay. Students, is it clear up to now? Students, is it clear up to now? Okay. Now, so in previous case, we just cutting plane is at here, and we just draw the projectors from all the points to their respective positions. Now, cutting plane at here, we just project the points to the respective positions. Now, let us see where your 1 point is existing. 1 point is existing in between B and C. 0.1 between B and C. So project your 0.1 to the respective position. So this becomes your 0.1. Next, 2 point is on. 2 point is on. Let us see, 2 point is on OC. So if you just project it, it is coinciding. It is not supposed to cut the generator. Then what to do? The same reverse procedure of the true slantage. So here, what is the true slantage here? OE and OA are the true slantage. So let us consider this point is going to be simply, I just consider now this point is K at this particular position. I just consider this point is K. Now O as center, OK as radius, rotate the R, rotate up to here to obtain the point K. Okay? Project this point to the O dash E dash, so this becomes your K. Once you have your K, if you draw the horizontal to meet the extension of OC, that becomes your 0.2. That becomes your 0.2. Students understand? So previously what we are doing, if 2 point is there, we just project that point to the true slantage and comes to the respective position and rotate to obtain this point. Similarly, I go for the reverse mechanism. Here my 2 point is there. I just consider it as some K. OK as radius drawn up to here. Okay, on OE, project it to meet the OE projector at somewhere at here and draw the horizontal. Okay, draw the horizontal to meet the extension of. So don't draw this much of the line. So draw the horizontal to obtain your 0.2. Next, there is no problem for 0.3. 0.3 in between OE. So directly if you just project this 0.3, you will obtain it here. This is 0.3. Okay. Next to 0.4. is on OE, point 4 is on OE. If you project this, you will obtain 0.4. Next, 0.5 is supposed to cut the base edge FE, 0.5 between F and E. F and E. So if you project that point up to here, somewhere at here you will obtain 0.5. Okay? Once you obtain all the points, join all the points in sequence. You will obtain like this. Once you obtain that point, that is nothing but your section shape. So section portion is to be drawn with your hatching. And the retained portion is, tell me what was the retained portion? Here is the observer. Portion between the observer and cutting plane is removed, and this was your retained. So that means this was your retained portion. So this was represented by, this is sectional front view. This was just top view. Okay. Now how can we obtain our true shape? True shape, directly draw the parallel line to your section plane. This becomes your new reference line, x1, y1. That becomes your new reference line, x1, y1. Once you obtain your new reference line, x1, y1, so draw the perpendicular projectors from all the points to the new reference line, x1, y1, and take this respective positions and place it here. Now let us see, one point is already on xy. So here it is one projector. So this becomes your point 1. Next, 2 point is somewhere at the distance of from here. So this becomes your point 2. Next, the 3 point somewhere at here. This becomes your 3. Next, 4. Next, here is 5 again on xy. So that becomes at here. Okay, so this was going to be obtained as your so this becomes your true shape. Okay, students. Is it clear now? Make it fast. Okay, students, shall we move to the next problem? Okay, all of you write a problem. A hexagonal prism of base side 30 mm base side 30 mm and axis 70 mm long. Has rectangular face in HP. Has rectangular face in HP. And axis parallel to VP. And axis parallel to VP. And it is cut by a section plane perpendicular to HP and inclined 40 degrees to VP, passing through a point on the axis forty mm from 40 mm from one of its base. Draw its projections. All of you just read the problem and try to understand it. Read the problem carefully and understand it. So let us see hexagonal prism base side of 30 mm and height of the axis is 50. Has rectangular face on HP, rectangular face. Let us see, this was a rectangular face. This rectangular face on HP like this, such a way that axis is parallel to VP like this. So let us assume this was a pentagonal prism, but let us assume it is a hexagonal prism having the rectangular face on HP such that axis is parallel to VP. So if you put like this rectangular face on HP, axis is perpendicular to VP. So you have to put like this. Okay. And it is cut by the section plane perpendicular to HP. Again, it is perpendicular to HP and passing through 40 degrees to VP. Cutting plane is cut like this, as like the previous problem, it cut like this, okay, and passing through 40 mm from the base, from the center of axis, it passing through like this and it is cut it, okay. So, draw its projections. So, can we put directly the position of your hexagonal prism directly in this view? So, we don't do like it. So, how can we do like this means, so let us assume first of all, the rectangular face is going to be on ground. So for that, first of all, you just see your axis is perpendicular to HP. Once if you obtain your axis perpendicular to HP, and once you just tilt it in such a way that, so that means your base is on the, that is nothing, rectangular face is on the horizontal plane. Okay, so we are not able to draw directly the front view like this. So first of all, we put the simple position axis perpendicular to HP. Okay, so once we obtain the simple position, you just tilt it for 90 degrees such that this rectangular face is going to be obtained on the ground like this. Okay, let us see. So the rectangular face is going to be, should be come on this means it should consider it as the edge basing problem. So if it is considered as a corner basing, so when you tilt it, the straight edges comes on the horizontal plane, but we require the rectangular face. Rectangular face means when you consider the base edge and top base edge are going to meeting, then it becomes a rectangular face that comes on the ground. So it should be considered as an edge resting problem. Okay. So these points are going to be, let us consider A1, B1, C1, D1, E1, F1. This was a prism. So you are having two bases. So this becomes P1, Q1, R1, S1, T1, and U1. We know the given side of the base is given as, side of the base given as 30. Okay. And you take the center, this becomes your O1 of O2. Okay. So the height of the solid is given as, the height of the solid is given as, tell me what is it, height of the solid is 70. Tell me the points when you are going to be seen from the front. B, C, D are visible, A, F, E are invisible. So this becomes B1 dash of A1 dash. So this becomes your C1 dash of F1 dash, E1 dash of E1 dash. Similarly, bottom base here. So this is Q1 dash of P1 dash, R1 dash of U1 dash, and it is S1 dash of T1 dash. This is O1 dash, and it is O2 dash also. Now you just consider, so this was step 1, step 2. Now my requirement is this rectangular face comes on the ground. So that means you just reconstruct the figure. That means this rectangular face STDE is going to be your rectangular face that comes on the ground. Okay. And when it is going to be tilted for 90 degrees, what happens? Let us see. So this is O1 dash, this is O2 dash. So this becomes B dash of E dash, C dash of F dash, D dash of E dash. And this becomes Q dash of P dash, R dash of U dash, S dash of T dash. So I just reconstruct the figure such that my rectangular face on ground. Okay. So this becomes your step 3. So when you are supposed to see the top view, so I require my top view. How can we obtain my top view? Draw the vertical projectors from here and draw the horizontals from here. Okay. Now mark the intersection points now. So which is going to be visible? Okay. While you are supposed to see from the top, let us see which points are going to be visible. So that means B, C, D are going to be visible. That is BQ, CR, which is going to be visible in front view. Now let us put the points first. Okay. Now mark here the points are F, Okay, so the points are going to be visible are P of t, Q of s, and A of e, B of t. So how can you simply put your, when your observer is going to be seeing this pattern, so which are going to be visible? So A, F, B, C are visible and ED are invisible. Similarly, TS was invisible like this. So I just place my points like this. Okay. Now, first of all, I just want to join this. Okay. Now let us take your cutting plane. So your cutting plane is supposed to pass at which end? It is perpendicular to HP and it is passing through a point which is on axis 40 mm from one of the base. Let us consider this was one of the base. From here this was total it is 70. From 40 let us consider it here this was the point. Okay, and it is going to be inclined 40 degrees to VP. Inclined 40 degrees to VP. So if it is inclined 40 degrees to VP means it should pass like this. It should pass like this. Okay, so this was your ticket ends. So this I just represent as HT. Okay, so this inclination is going to be considered as, for example, if you just consider this as, this inclination is 40 degrees to VP. For your reference only that was. Okay. So this distance from the base is, it is from here to here it is 40. Now mark the points. Now mark the points where it is going to be. Always start from the extreme left. So this becomes your 0.1. Next this is 0.2. Next axis no point. So this becomes 3. So here it is 4. So it is AF is going to be base. It is going to be cuts the base means you obtain 2 number of points. So when I start from there, so I just get another point 5 point. Where it is means, that is I just write here 0.1 for 0.1 between R and C. Next 0.2 between Q and B. 0.3 in between P and A. Between P and A. Next 4 point. So 4 is on base edge between A and F. A and F. Next. So 1 to 4 is going to be, these are points from left to right. Okay. Left to right. Once we move from left to right, once it is going to be ends the position, again we start from right to left from that particular point only. Why? Because in base you are going to be having 2 points. That means AF is visible edge and EF is invisible edge. So fifth point, base edge between E and EF. Next 3 comma 6. 6 point is in between E and T. 0.6 between E and T. Next 7 point is in between 2 comma 7. So that between then between S and D. So these are from right to left. So from this we can say this was visible points. That means visible points obtained on solid lines. So next, these are invisible points. Invisible points on invisible lines. This thing. Okay. Students, is it clear how to obtain the points? Students, is it clear up to now? Students, is it clear? Next step, what is the next step? Next step, let us see when the observer is going to be seeing in this pattern, from this pattern. So which portion is to be removed? Always the portion between observer and cutting plane is removed. Okay, that means this portion is removed and this was my retained portion. The retained portion is going to be so this was the axis. Okay, this was the retained portion. This was the removed portion. Portion between observer and cutting plane is removed and remaining is retained portion. This was retained. Next, project the points to the respective positions. One point is in between R and C. One point is in between R and C. So this becomes your point 1. Next 2 point is in between. First of all, it is Q and B. So this becomes your 2. And 7 point is also in between S and D. This becomes your point 7. Next 3, 6. 3 point is in between P and A. Six point is in between T and E. And fifth point, fourth point is in between. Fourth point is in between FA. In between F and A. How can you get the point? All of you see, this was the, all of you just stop doing and let us see what I am going to do. So if you just extend the 4 point, it will coincide with the base edge. When I am suppose my projector cuts the base edge, then I get my point. So if you project this, then what happens? It will, what is coming? It will coincide with the edge. So the procedure is, so let us see 4 and 5 are in between A and F and E and F, right? So simply I just project my point to the respective base positions. So let us see. So this was my, sorry. I just project this 4, 5 to the respective base positions at here and here. So why? Because 4 point in between A and F, this is 4 and this is 5. Okay. Now project these points to the respective positions. Okay. And so let us see. So I just project where is your 4 point is in between A and F, right? So I just project this line to vertical. So this becomes your 4 and 5 point is in between E and F. So I just project from here. So this becomes your 0.5. Now you can see this 4 point is going to be obtained in between A dash and F dash. So let us take this radius. So B dash 4 is going to be taken as radius, B dash as center, draw an arc to obtain your 4 point. Similarly, C dash 5 as radius, C dash as center, draw an arc to obtain your 0.5. Students, is it clear now? Do you understand how I obtained my points 4 and 5? So if you project 4 comma 5 directly towards the base, it will coincide to the base edge. For that only I just project my points to the respective positions on the base. So in between A and F and E and F. So it is 4 and 5. So if I just project this point to the respective positions, okay, so 4 and 5 are going to be obtained in between AF and EF. So I just take this radius from here and place here. I just take the radius and I just place here. Okay, now join all the points. Now join all the points. Now join all the points. Okay, students. Once you join all the points, so that means, so that was the retained portion. So that was a retained portion, and remaining is to be this was your retained portion. So this was so okay, don't get confused. So this was the retained portion, right? Only the portion up to here. So this was the retained portion. So this becomes your sectional front view. Okay, so this becomes top view. So how can we obtain our true shape? So draw the new reference line which is parallel to HT. X1, Y1. Now draw the perpendicular projectors from all the points and place it from the new reference line. So 1 point, this is your 1. Next, this was 2. 2 point is going to be, and 7 point is on XY. Next, 3 point. Next, so this was your 0.6. 6 point is on XY. Next, this was 4 and this was 5. Now join all the points. So this becomes your true shape. So draw the perpendicular projectors from all the points to the new reference line x1, y1 and take the distances from old reference line and put it from the new reference line. Students, is it clear? 5 and 4 are misplaced. Where your 4 and 5? Let us see, 4 and 5 are misplaced. 4 point is in between AF. So 4 and here it is 5. It's okay. Students, can you tell me where it is? Where it is misplaced? 4 and 5? I didn't get anywhere at here. Yes, in true shape, right? Yes, in true shape. Yes, in true shape. So 4, 5 are misplaced. Students, is it clear? Okay, students. So today we will stop here. So this was the end of the section of solids. So yesterday we think of the thought of starting of the development of surfaces, but the time is already 5:45. So tomorrow we will start the development of surfaces, the fresh chapter. Tomorrow we will discuss the developments of surfaces. Okay. So all of you kindly go through the problems which we discussed so far. All of you wait a second. I just dictate some of the problems in the textbook which you had to see in the sections of solids. You just tick the problems or note it down and you just practice those problems. Okay. So the problems are problem number 14.5, 14.5, problem number 14.5, 14.7, 14.7, 14.5 and 14.7. Next problem is 14.10, 14.10, 14.13, 14.13. Okay. Next 14.17, 14.17, and 14.22, 14.22, and 14.24, 14.24, and 14.25, 14.25, okay, and 14.29, 14.29. So these are all the solved examples in the ND textbook. These are all the solved examples in the ND textbook. All of you kindly go through those problems and practice them. Okay? Okay, students? Have you all marked those problems? You just mark those problems, and those are the solved examples only. You just had to practice those problems. Okay? Students, student, someone had raised the doubt. Student, can you repeat the doubt? What is it? Can you repeat the which step you just wanted? Which step? Student who had asked the doubt, can you tell me? Can you just type it again? Which step it is? Which step you required to repeat? How to draw the section plane? So let us see, students, this section plane is making, given it is perpendicular to HP. When it is perpendicular to HP means the top view is going to be obtained as your horizontal trace. So, and it also inclined, you don't confuse, the section plane is also inclined 40 degrees to VP. So 40 degrees to VP means that comes below XY line. So you just take your section plane inclined 40 degrees. First of all, you just take your drafter and fix for 40 degrees, and where it is supposed to cut this solid, at which position it is cut means it is going to be passing through an axis 40 mm from one of its base. So let us consider the distance. This is going to be some 40 from here. So this is 40 from this base. I just consider this point is going to be from here base, it is 40, and I just mark my point on the axis. So I just take my drafter for 40 degrees and I just draw a line passing through this center, this axis point, that is 40 mm from base, and I just draw a line of 40 degrees. This 40 degrees line becomes your cutting plane. Okay, students, have you understand now how to obtain the cutting plane? Okay. So all of you practice the problems which I given to you in the Rendiba textbook, the solved examples. Okay, all of you just practice those problems. Tomorrow we will start the new chapter, developments of surfaces.